Hi, everyone. Welcome to our first webinar of 2025. My name is Diana Sinton. I am a senior research fellow with the University Consortium for Geographic Information Science. And I'm here today wearing my hat as one of the co-leads of the iGuide team. iGuide is the Institute for Geospatial Understanding through an Integrative Discovery Environment. Today, we are going to focus on the topic of teaching and learning geospatial data science, one of my favorite topics. And I'm really pleased to be joined by a few of my colleagues here. Let's see, I'm going to advance this slide. UCGIS works with iGuide through part of its Community Champions program. So what this means is that each of the years of iGuide's 5 years of funding, we run a competition where people can submit small proposals to be able to work on an activity of their choice that is complementary to some activities that are going on within iGuide. From our 2023-24 cohort, we had Dr. Babs Buttenfield and Dr. Eric Money have their projects selected. Babs worked on a project titled Visualizing Uncertainty in Geospatial Data, and Eric Money was working on a series of case studies, which showed ways to use case studies as a mechanism to get to some ideas around convergent science. And we're also going to hear today, so what we'll be hearing today is from Babs and Eric Money talk about the work that they did on their projects and put that in a slightly bigger context. And we're also going to hear from Dr. Eric Shook from University of Minnesota, who is a co-lead along with me. He works with iGuide's Education and Workforce Development team. We know that this is a really important topic for all of us involved in higher education and geospatial data science. I was thinking about this again. Some of you might have already seen this in the winter ARC news. We had our colleagues Tristan Nelson and Peter Kedron from UC Santa Barbara talk about the new teaching modules that they'll be coming out with at Santa Barbara around some of these topics. I hope we'll be able to highlight the work they're doing at another time. And with that, I am going to turn this over I'm going to turn this over to, we're going to hear from all three of our speakers today, and we're going to have enough time for a little bit of Q&A as well. This is a regular Zoom meeting, so please keep yourself muted. Put a note in the chat, please, if there's something that you'd like to ask, and we'll be able to get to it later. At this point, I'd like to stop sharing my own screen and turn this over to Babs to begin our conversation today. There we go. Excellent, Babs. Yep, we can see your screen just fine.
Okay. Oh, there we go.
There you go. Yep.
Great. Let me move you folks someplace else. All right. I'm going to talk about a specific case study. This is a story about how that case study turned up on my desk in Buffalo, New York, evolved into an opportunity to teach beginning GIS students about geospatial uncertainty. It centers on a problem facing many growing suburbs, intrusion of deer into neighborhoods, and the ensuing deer vehicle accidents. How this all started was that in 1992, sorry, I have to move you folks out of the way again. I'm not sure where to put you. Let me try down there. In 1992, a fellow named Steve Parkansky started doctoral work with me and David Mark. Steve was a non-traditional student. He came to Buffalo in his mid-30s to change careers. He's now on the faculty at Morehead State in Kentucky. Now, how this all started, Buffalo is a community of neighborhood pubs. People make friends over beers and wings, watching Sunday football games at the pub. Steve became friends with the police from Amherst, which is a suburb of Buffalo, who talked about a recent increase in deer vehicle car accidents. It turned into a dissertation for Steve and a very rich case study on uncertainty for our classes. It also evolved into a new strategic planning task for the town of Amherst, modeling possible green space corridors for the city of Buffalo. But today I'm going to focus on just this first step, mapping data that is uncertain and how to teach beginning GIS students how to mediate uncertainty in the data. So the purpose of this teaching model was to show students how to collaborate with uncertainty rather than to ignore it or hide it or fight it. This was a first semester GIS class. Students had ArcMap mapping skills, but not much experience yet with geospatial data management. And remember, this was the early 1990s, 93, 94, when Esri software was the much wanted skill set. So that's why the ArcMap was there. It would be taught differently now, I'm sure. We taught through lectures, demos, labs, class discussions. We assigned conventional readings from journal articles on uncertainty, but I also assigned news articles from all over the country. I'll talk to you about how we structured the class activities, about how we dealt with uncertainty for 2 or 3 different examples and lessons learned. So the context, I'm sure you're all familiar with this if you've ever lived in a suburb of a large area, is deer intrusion into residential areas. Deer have very few natural predators. In a suitable habitat, there will be a population explosion, and deer tend to damage high-valued vegetation, particularly riparian habitats, nesting for native plant species, but also crops. And north of Buffalo, there are a lot of fruit farms, cornfields, and vineyards, actually. And then, of course, when you have a lot of deer, you're going to get deer vehicle collisions, especially in areas of fast suburban or exurban growth. And this becomes a real hot button issue, as it turns out. A little bit of context for those of you who don't know Buffalo, New York. I encourage you. It's a great place to go. Let me just give you a quick geography lesson. This is the area I'm going to be talking about. Buffalo is down here at the star, and you can see the star in the satellite image up into the northwest corner of this box, what's called Amherst. This is the Niagara River. It is the international boundary between the United States and Canada. And this place right here is Niagara Falls. You can see it up here. There's Lake Erie to the south, there's Lake Ontario to the north, and then there's Buffalo City. You can see some of the development here in the satellite image, and if you go far enough east, you will get to Rochester, New York, but that's not in the image. So the Niagara River is bounding US and Canada, and the speed of the Niagara River normally is about 25 miles an hour. So this is not like a little creek that deer can jump across. It's a barrier. Buffalo in the 80s was a hub for steel production, and it still is a hub for hydroelectric power. So there's a lot of industry there even now. The terrain is quite flat. Wine country to the north of town. This is Welch's grapefruit juice country, also vineyards. It's a great habitat for deer population to explode. Very few natural predators, as I said, not much development in the north, and Niagara Falls is a huge tourist attraction, so lots of traffic. When the steel industry went bust in the 1980s, a lot of blue-collar workers lost their jobs. There was no retraining back then, so there was an influx of high poverty. Lots of under-the-table industry sprang up, like deer pickups by contractors after the accidents, people driving around picking up deer, cutting off their heads and taking them to the police. They got paid by the head. They would sell jerky or smoked venison on the side of the road. This all led to a white flight to the suburbs, which takes us out of Buffalo and up into Amherst. You can see that bounded in a red line. And this left an amazing racial and income barrier in the region. Amherst became one of the most affluent and fastest growing suburbs in New York. So you can see up in the north here, not very much in terms of local streets. So this is pretty much open space here. But you see coming down into the cities, and I'm showing you 1993 street data and highway data. As you come farther south, you can see that there's a lot more people. So there's interstate highways, there's this very fast-moving river, there's Lake Erie to the southwest and Lake Ontario to the north and Rochester to the east. And all of this open space up here and even farther north in the agrarian, lots of deer, no place to go, which is where our story picks up. Sorry, I'm getting messages from you. So if you look at this, you can see this rise from 1992 to 1996, a steady rise in deer auto accidents up in Amherst, that where I showed you, and you can see some of these mapped. And down here, you can see a deer count. This is a deer count from the Department of Natural Resources, going from just over 200 deer up to just under 1,200, probably a 5-time increase. And down here, you can see the contractor pickups. These are the private contractors who would drive around and pick up the deer and take the heads to the police. It was a budding industry at the time. So you have lots of people, you got lots of cars, you got lots of deer, you've got lots of car-deer accidents, and residents wanted something done. So that's the context. Prior to getting the class going, the lab exercise scenario for these first-year GIS students was download data layers from various online sources, mediate the uncertainties, and generate a map for the Town Council of Amherst showing the deer vehicle accidents as well as the uncertainty. So we started by talking about federal, state, local, and so forth sources for each data layer and their possible biases and the possible uncertainties in the data. Class discussion, a little bit of lecturing. We talked about who were the stakeholders and what kind of opinions they might bring to the table. These are some of the data layers we had. You can see most of this is public domain. The police blotter and the contractor pickups were from the town of Amherst. This was Steve and his beer buddies from the pub. He got the police blotter and contractor pickups, and I'll show you that data in a moment. But everything else is public domain from the State Department of Transportation, federal U.S. Census. We also got land use from USGS, riparian data for wetlands and hydrography, and then the state DNR counts. So initially, this was an exercise to teach students how to download data on the internet, but also it was an immersion in data reliability. Let me show you some of these data uncertainties that we had to deal with. So this is an example, just an excerpt from the police blotter. Now, this is just a computer printout. You've all seen, I think, computer printouts, like 10-point type, pages and pages and pages of it. There were hundreds of these reports. And I want to talk to you about how you turn this stuff into coordinates. So this is a deer vehicle accident that was midway between New Road and Transit Road, 2 roads in Amherst. Driver wants to keep the deer. That's very common. Here's another one. The deer is on the right shoulder, possibly injured, and then later on, dead on arrival between Dodge Road and Smith Road. You know, there's no coordinate here. There's no latitude and longitude. And so the question is, how do you actually turn that into a mapped coordinate? Here's 3 kids with an axe who found a deer in a ditch between Millersport Highway. Somebody from 2446 Sweet Home Road reported it to the police, and the police came and told the kids, you can't start chopping things up in the middle of the highway. At any rate, a lot of this stuff. And Steve had hundreds of pages of this stuff, and he had to turn it into coordinates. So how do you situate poorly described locations, because it's obviously not all addresses, consistently? Now, David Mark was really a pro at this, and I was so happy to have had the chance to work with him on it. Here's an example of how we dealt with midway between 2 intersections. You can start by putting something exactly halfway between, and then you can add a random generator that'll slide it one way or the other randomly. But you also have to come up with other kinds of rules. You have to come up with midway or between 2 intersections. But you also have near. Near an address is easy, but what about near a shopping mall? Shopping malls are big and they're multi-sided. Close to, next to, in front of. Each one needs a rule, and then you have to geocode them consistently. This particular problem was difficult enough that we didn't give it to the first semester students. We solved it for them. But the 3 of us, David, Mark, and I, and Steve Parkansky, we drank a lot of beer over this. This is one of the sources of accident reports. Here's another one. This is private contractors. Now, if the contractor picked up a deer and brought the head to the city, they got paid, but they had to record where the pickup happened. So they're driving around in their trucks, throwing the deer in the back of their truck, cut off the head, take it to the police, and then take the deer home and smoke it for jerky or cut the pelt and sell it on the street. This was the budding industry. But I want you to see these. This is just a legal pad that a guy's got in the, seat of his truck, and he's just writing down because he has to show where he got the deer from if he's going to get paid, or she. So here's one near Mason and Tonawanda Creek. Here's the next one, about 100 yards from the first location. So you've got absolute locations, you do have addresses, but you've also got relative locations, and you have to follow the same set of rules that we did for the police blotter for the deer contractor reports. And Steve had about a year of these for both of them. And when you put them together, the stars are the police blotter reports. You can see that they're very prominent and prevalent in the southern part of Amherst, but as you get up farther north, up into this open space in agrarian, this is mostly contractors. The circles are contractors. And some places they coincide and they match up, but some places they don't. And what happens if you've ever hit a deer, I feel very badly for you and certainly for the deer, but the deer doesn't necessarily drop dead on the spot. They'll jump over a couple of fences, they'll go to a deer ditch. Who knows if it's the same deer that's a half a mile away or a quarter mile away or right next to it. So there's a lot of uncertainty in this data. But both data sources are credible, both are equally valid. And so this was the first set of coordinates we gave to the students and said, now you tell us how you would like to figure out and mediate the uncertainty here. We talked about it. Here's another example. This is transportation networks. This is the gray lines you see are Tiger local roads, and the green are arterials and interstates in the area. And in brown, you can see the New York State DOT arterials. And you can see, I'm going to blow up right here in the middle so that you can see in some places they match pretty well. And in other places, well, not so much. And so the question is, where do you put the arterial? Now we had the police blotter reports were addresses, and so we used the Tiger local roads. So does that mean you use the Tiger for all of the arterials, or do you go to the more often updated state DOT? We talked to students about that. Or do you build a buffer around the two and create a new medial axis transform? And we talked about, the upsides and downsides of all this, and then the students worked on that with our help. Here's another example. This is wetlands from the National Wetlands Inventory. You can see it pretty easily outside the boundaries of Amherst. This is kind of the gray stuff. And the slightly more prominent stuff, the Natural Resources Conservation Service wetlands. They both have wetlands. You can see those are kind of the green striped. Now, when you have multiple data sources that are equally credible and the data layer like wetlands is really tricky to define in the first place, what I've always been taught is intersect the two, because those polygons that appear in both data sources can be assumed to be more certain, meaning you're definitely going to need galoshes in the wetlands that are bright green. So that's what we did in the end, and the students all ended up doing this as well. So our wetlands matched up pretty well from one student to another, the bright green, and throw everything else out. So you're giving up a lot of data when you're mediating uncertainty at times, but if your purpose is to show more certainty, then sometimes that's what you have to do. So after the lab exercise, we talked and summarized the geoprocessing methods. You can see all of the different things that they did. They intersected polygons, they did unioning. These are all very basic GIS 1, but they had to understand as they went along that their conclusions would be less specific, and they would lose some data along the way. So they mediated uncertainty using geoprocessing and mapped the accidents. We posted all of the student maps and let the students look at them, and the students saw that no two maps had precisely identical data. This case study was a great way to show undergraduates that it's hard, even with a systematic approach, to get to a single truth. The bottom line, uncertainty isn't something to be deleted or avoided. And again, we were trying to get students to collaborate with it, to deal with it using geospatial tools at hand, and to be transparent about their processing. So our lessons learned. The first lesson that we learned is that some problems are trickier than others. For us, it was the locative descriptors, in between and near and so on and so forth. So if you're going to bring a case study into a class, I guess the advice is resolve all of the data problems before you ask students to do so, and then you'll have a much better feel of what they're qualified to handle on their own. The second thing is that class preparation is going to take a lot more time than you think. So use what I think of in teaching as structured iteration between lecture and discussion, software demos and lab work. Show students directions to find answers, but leave them motivated to find the answers on their own where they're qualified to do so, and be transparent about how much you've solved for them. And tell everybody what you're learning along the way. So for teaching the case study, these deer vehicle accidents began as a data download and mapping exercise, but led to this rich discussion about uncertainty and political bias and social implicit bias. And for Steve, it turned into a dissertation. And for the town of Amherst, attempts to mediate the accidents evolved into a partnership with a local university and a community website that they built, allowing citizens to participate. Hey, I hit a deer over here, and so on and so forth. And then a planning strategy for the immediate future, all from a couple of beers over a few Sunday football games. Thanks very much. I'm going to stop sharing here. Go.
Thanks, Babs. I like the way that you profiled that case study as a format for teaching, and how uncertainty was characteristic of so many of the facets that you looked at. You know, you're known for your work both through cartography and as a GI science scholar around uncertainty. Are things like case studies one of the approaches that you have found to be most effective over time?
You know, over the years, yes, it's a lot more interesting to students, especially in Buffalo. These students were in Buffalo. A lot of them had deer vehicle accidents, but I find that bringing it home with current events, students could look at the paper. They could see the police blotter reports that were published weekly in the paper and start counting it up. And then they could go to these places and say, wow, this is a really dark intersection. Maybe the city should put up lights. And so they'd started to get involved in the community themselves. So I find that if you can find a current or even a historical case study, it's going to be a lot more interesting for students. You're exactly right.
Yeah, I really like that aspect of I mean, conceptually, we all get the idea of where something like a crime happens, something like a deer collision, deer vehicle collision. You appreciate the extra parts of it, that the deer doesn't always stay right where it was first, where the collision first happened, and all the different nuances.
You know, it's interesting that you bring this up about seeing things in the paper about where something happens. You know, if there is no deer vehicle accident, or in the case of crime data, if there is no crime, there is no data point. And so it's very hard to tell students about, oh, this is a great place. Deer accidents aren't going to happen here because there's no data there. And that was one of the hard things to get across in not only this exercise, but in other exercises. We did one in Denver crime mapping. You know, if somebody goes to a bar and they get out at the bar at 2 in the morning and they take a bus back home and they get home safely, there's no data point. So does that mean it's a safe place? Well, not necessarily, as you know, and I won't go too far down that path today, but
No,
yeah.
exactly. Like, but what exactly has to happen before the highway department puts up a sign that says deer the next 2
Yeah,
miles or?
right, right.
All right, excellent. Let's hear a little bit from Eric Money and the way that he has used case studies in his work as well. The materials that so the recording of this webinar will be put on the iGuide website. The materials that Babs and Eric Money have worked on for their iGuide, for their UCGI's Community Champion project, are being integrated into our convergence curriculum, and you'll hear more about that from Eric Schlick in a little bit. But Eric Money, I'll turn this over to you now, and then Eric Shook, feel free at the end of Eric's to jump on and share your thoughts as well, your materials.
Yep, will do. All right, thank you all. Let me get my screen sharing here. All right. Everybody see screen?
Yes, we can.
Okay, awesome. Okay, so I'm Dr. Eric Money. I'm an associate director in the Center for Geospatial Analytics at North Carolina State, and I'm happy to be here with you today to talk a little bit about what I did for my community champion project with UCGIS iGuide. So in sort of long text form, as you can see on the slide, the title of my project was Case Studies in Convergence, Deconstructing Geospatial Connections to Frame Convergent Problems Across Disciplines. That's really a long way of saying developing case studies that can be used, in a modular way to help, in a broad sense, teach geospatial science concepts, but using the convergence curriculum that's been developed within iGuide as a guide for delivering those case studies and sort of bringing home this aspect of convergent problems and what those problems might look like across disciplines. I've always been interested, as many of you in GIS world are probably became interested in GIS because of its applicability to all different sectors of society. And so part of what I wanted to do with this project was to think about how can we use the sort of framework of the convergent curriculum to create case studies that span both sort of a natural science perspective, but also a social science, humanities perspective, so that we could perhaps introduce these concepts of geospatial data science really across, in my case, across the university for students that may just be getting into the world of GIS, geospatial science, and the such. And so what I did for this project was, I'm not an expert. I come more from a natural science perspective, so definitely not an expert on the social science side. So what I wanted to do was to develop these case studies in collaboration with other people at the university. So people that are actually doing work in a particular area that could benefit from the use of geospatial data science in one way or the other. And so basically what I did was I met with several different researchers and professors across sort of the natural science area. So here at NC State, we have College of Sciences, College of Natural Resources, College of Engineering, College of Vet Med. All of those I kind of reached out to kind of first kind of explain what I was trying to do, and then set up a meeting with them to kind of walk through this sort of development of these case studies. On sort of the social science humanities side, I talked to our College of Humanities and Social Science. I talked to folks there about also potential ways that they could envision using geospatial data science. And so essentially what I did was I went to these individuals, we kind of sat down, and I really, and again, some of these are individuals that they don't necessarily use a lot of GIS currently in their daily lives. Some of them do, some of them did, some of them didn't. But really what I wanted to do was kind of basically take with me the convergence curriculum framework that's within iGuide. And that's kind of where that was our starting point. I kind of presented that to them as we sat down and just started talking. And I asked them, and I kind of walked through, from my geospatial expertise, kind of walked them through the framework and then had them kind of go through this thought process of, okay, let's look at specifically the knowledge connections within the framework and think about how can we develop a case study in this area that would help us to, in a broad sense, discuss each of those different knowledge connections. So I did that sort of on the, again, natural science side, and I did that on the humanities and social science side as well. And so the result of those discussions is really what I'm presenting here today. And we basically came up with sort of two pretty specific case studies. Again, these are going to be sort of high level, meant to really just kind of introduce the concepts within the different knowledge connections of the convergence curriculum, as a way to introduce this idea of sort of, big problems in society that require, again, convergence and a lot of different knowledge areas to really develop a solution. And so in one example, we developed a biosecurity case study, and then we developed a cultural heritage case study focused on cemetery plot mapping. In addition, I created some instructor guides that would provide some potential scenarios that could kind of help an instructor kind of kick off the use of these case studies in the classroom, or even in sort of a non-formal setting to introduce students, I would say, high school, undergrad level, to these concepts of geospatial data science. And then kind of compile all this into a website that's open to the public, that you can go and you can download the case studies and the materials that I'm talking about. And so I'm going to just go to the website now, because that contains a lot of the really sort of nitty gritty of the work that was done for this. So as I mentioned, we developed two case studies, one focused on biosecurity and the other on cultural heritage preservation. And so on the website, basically what I did for each case study, and again, these are the results of these discussions that I had with researchers that are actually doing work in this area, is that I wanted to start out by sort of introducing sort of what's the big picture. And then for this particular case study, it's really talking about biosecurity within the pork industry. And so sort of the big picture, kind of setting the stage for the case study, for this particular case study, is really focused on infectious disease and infectious disease spread within livestock, whether that's the African swine fever or foot and mouth disease, et cetera. And so the idea is just kind of set that big picture stage for students about what this case study is going to be. And then I also use this as a way to introduce the convergent curriculum itself. And again, I'm really focused on those sort of 5 knowledge connections that are a part of that framework, and basically introduce students to the idea of, what is a convergent problem and why is this particular problem convergent, for example. And so in this case, it pulls together multiple domains from epidemiology to agriculture, environmental science, biology, as well as geospatial data science tools and methods across the curriculum. And so for each case study, there's a graphic like this that sort of highlights sort of what are some of the elements within geospatial data science that would correspond to those individual knowledge connections, and as well as, what domain knowledge might be necessary to help answer the case. And so then we get into specifics about the actual, presenting a scenario. So they're presented with a scenario in this case about an outbreak, and your objective is to develop a geospatial model that integrates various data sets to monitor the spread of this disease and identify high-risk areas. And so then basically the case study runs through each of the knowledge connections in more detail, whether that's data mining, so describing, what are the different data sources and how to go about getting those and using those, evaluating those. The geospatial analytics part in terms of what are some analytical tools that might be helpful, such as hotspot or network analysis and risk mapping. We talked about computing in terms of like predictive modeling, geovisualization, whether that be, in this case, a dashboard as a possible avenue, and then the geoethics knowledge connection that is part of the framework. And so then it kind of leads, finishes off with some outcomes and recommendations related to the case study. And then there is sort of a very brief sort of, okay, so what are some specific tools and tech that we could use to answer this problem? So the case study is not, it's really, again, kind of meant to be a big picture, broad sort of overview of a convergent problem and how we could go about coming up with a particular solution to a particular problem. It's pretty open-ended from that point on. So, the instructor can use this sort of framework of a case study to present it to students in a lot of different ways. My initial ideas with this is to basically, again, use it to introduce these concepts from geospatial data science at a very high level. And then obviously, if you wanted to go into more deeper level of actually obtaining some of the data, having students do some of the mapping and all that kind of stuff, then obviously that's a good next step for this kind of stuff. But this is, I think, meant to be a very sort of broad, introductory, all-encompassing kind of introduction to geospatial data science for people that are, maybe have never even heard of GIS before, and they're getting this material for the first time. And so similarly for the sort of humanities social science case study, this again was focused on this combination of domains, whether it's conservation, land management, archaeology, sociology, history, with the objective coming from this idea of looking at a historic cemetery in the southeastern United States. Has a lot of historical significance. Maybe there's a lot of important individuals buried there, notable figures in politics and art and business, and it's a focus for preservation. But the cemeteries face a lot of challenges, and so the objective is really to create high-resolution geospatial maps of the cemetery using modern geospatial techniques. And again, similarly to the biosecurity example, we start with looking at the how is this connected to a convergent problem, and using, again, the framework and those 5 knowledge connections to kind of, again, high-level introduction to these different potential ways of addressing this particular objective of the case study. I also mentioned as part of this, I wanted to create some guidance for instructors to actually use these case studies in the classroom. Again, I see these sort of as modules that could be incorporated into a larger class around geospatial data science or introductory GIS or anything like that. The impetus for us at NC State for doing this, and for me for doing this project, is that we are really in the stages of developing new curriculum at the undergrad level, particularly around geospatial data science and analytics. And so I really saw this as a good way to develop some modules for one of the intro courses that I teach in spatial thinking. And so there's an instructional guide on the website. It includes some potential scenarios for how to use these case studies. Things like, the instructor can present the convergence curriculum for data science and ask students to brainstorm what they believe to be convergent problems. And then this could be followed up by introducing these specific case studies. You could present the students with the case studies. However, you could leave out certain details, such as some of the data or some of the techniques, some of the analytical techniques, and so on and so forth, and have them identify some of those things as well. Third scenario, you can present the full case study and really just do reflections with students, ask them, are there gaps that they see in those case studies, other types of data that might be helpful, etc. And then obviously you can go into, like I said, sort of build off of this to really go into acquiring some of these data sets, walking through some of the analysis and visualization down the road, depending on the level that you want to kind of teach at. I also created, as part of this, just some initial knowledge quizzes that could be used to sort of help guide students and teach students some of the lessons. And then finally, like I said, this is a public website. The idea was to make this available for anyone that would want to use it. There are downloads where you can basically download PDFs of the full case studies. So essentially what's here on the website, along with the knowledge quizzes and an answer key for those knowledge quizzes. So ultimately, the goal of this project was to work with researchers and experts in sort of a natural science arena, as well as a humanities social science arena, using the convergence curriculum as our guide, as our initial guide for discussion, to develop these case studies kind of from the ground up in real world sort of situations and projects they were working on. And then build that out into a high level sort of introductory way of getting students from all kinds of disciplinary backgrounds that are new to GIS and geospatial science, a way to kind of see the convergent nature of geospatial data science as they're just getting started into the geospatial world. And that's all I had. Stop sharing.
Wonderful. Thank you.
Yes, thanks, Eric.
Yeah, I'm blown away, and I'm so happy that both Eric and Babs were able to be our community champions and work on these very important case studies. I think what I draw from this in terms of the convergence curriculum is that we have always kind of found that connections was really the part that we wanted to emphasize. I'm not going to belabor the point too much, but I will just do a really quick slideshow here that pulls from slides that actually kind of came almost before we started talking about the curriculum, right at the beginning of iGuide, where we said that the traditional model of university education follows what we call the T model, which is, you kind of have your gen eds, your liberal eds as your knowledge breadth. You have a major, which gives you some depth, and this is called, the T model. Then we have the pi model, where you have a double major or a major minor, which is becoming more and more common. People trying to combine different areas, but it's really up to the learner to make those combinations. So the word that I was getting pulled out, or that was pulling out in my brain from both Babs and Eric, was the word connections, which is great because the model that we were trying to push when developing the convergent curriculum was actually what we were trying to generate was the U model, where deep down at the bottom of that knowledge depth is that we wanted to actually facilitate that level of connection. And the challenge with that is when you're developing a curriculum, generally they tend to be fairly linear. So it's very easy to come up with the T and the pi model, much harder to come up with the U model. So when we developed the convergence curriculum, which was a very iterative approach, following feedback from the community and everything else, we really did try to build in these connection points. But what struck me listening to the presentations, but also kind of following along with the work that Babs and Eric has been doing over the past year, it strikes me, and I'm curious to hear Babs and Eric's comments on this, and then we can also open it up to questions. Is the convergence curriculum, we have these components. Eric focused very much on the knowledge connections, kind of the middle piece. And then Babs, I think, touches actually quite a few of these things through her case study, which is interesting. And what kind of stuck in my brain was that these components are necessary but not sufficient. And in order to really get to these connection points that we're really striving for, we have these in the diagram that connect the components. But if we really want to get to this U model, do we have to have these case studies? Because I was kind of thinking yes. And what's interesting about that is the summer school that iGuide has hosted every year, that was also preceded by some other summer schools, actually uses these very authentic research problem during the week of the summer school, which kind of provides a similar set of case studies, allowing you to kind of mix and match and combine and gain knowledge depth. So I'm curious on your, I'll stop sharing my screen here and I will open it up first to Babs and Eric. And then I also want to make sure we leave time for questions. But in your experience working over the past year, and kind of looking at the curriculum model and then basing it off of your experiences, you know, is the case study really like the pinnacle point at the end that we need?
I'll go first and then pass it over to Eric. I think that for me, I want to motivate my students to learn for themselves. And I think that is where the U model comes in. And you can do that without a case study. You can do it with a case study as well, especially if it's something that their students are really interested in. So if it's biodiversity that Eric was talking about, or agricultural science, the swine flu and so forth, or if it's something historical, you know, if you can hook a student's interest, all you have to do is point them and let them stumble around a little bit, just like we do when we learn, but realize that they can make these connections for themselves if they are motivated to do so. So can you do that with case studies? Yes, but you can do it in a number of other ways as well.
Yeah, and I'll just add that I don't necessarily see the case studies as the end, but more of the beginning of the process. It's for me, developing these were really meant to be a jumping off point to then delve deeper into the different connections. But really, you know, my goal with these was to first make the point that solving problems is not easy, and that there are lots of different perspectives and disciplines that go into solving most problems. It's not just, you know, for biosecurity, it's not just agriculture, but it's also a number of other things that would be involved in that. And so it's one way to get students from a lot of different perspectives interested in the topic and then letting them run with it. But it also provides a little bit of a, to me, a little bit of a scaffolding to get them started, so that they're not just kind of floundering around all over the place. It gives them a little bit of a sort of concrete way to start thinking about problems, whatever that problem may be, from whatever their interests may be.
Oh, interesting. Okay, yeah. So it should be the beginning, which is kind of the hook that Babs was also mentioning, to really get them motivated. So, oh no, that's wonderful, because this year the focus on the curriculum is a little bit more on kind of deployment and seeing where it fits in these sorts of things. So this is, you know, in my brain right now. So these sorts of comments are phenomenal. What I did want to do was open it up for questions as well. We have about 10 minutes left. So I'd like to kind of see if there's any questions out there. Feel free to unmute your microphone if you're comfortable with that, or we can also read questions off of the chat.
As people are thinking about their questions, I was thinking too about the role that case studies have played over time, with ethics, for example, how successful the case studies within the use of case studies to illustrate topics within geoethics. I'm thinking of the one that Penn State had started, and just I remember talking with David DiBiase about how there's nothing besides a case study that could have let them cover both the breadth of topics and the important details of that get into some of the depth there.
I will jump in to answer Karen's question in the chat. What do you mean by deployment of the curriculum? So I try to actively avoid the word dissemination because it's very much a push model. So We're looking to work with educators and other sometimes trainers in a kind of non-traditional educational setting to see where some of these curriculum components might fit, um, especially outside of just GI science. Now, GI science is my field and my people, which I love. But if we're talking about convergence, we also want to test to see how these fit into other areas. So especially, seeing how in the social sciences with different theoretical frameworks, conceptual frameworks, teaching methodologies, how these fit. Environmental sciences, ag, these sorts of things. So just trying to see the space where this might add some value, especially as things like data science come into fray, and we're looking at the more domain application rather than just the statistics computer science piece of data science that most universities are really focused on right now.
If I could respond quickly to Diana's comment about ethics, I see ethics as so wrapped around uncertainty, whether you're visualizing it or reporting it or talking about errors in your statistical analysis, root mean square error, for example, but other things as well. All of the uncertainties in data may not need to be reported in gory detail, but at least you need to let people know that your data is never perfect. And here are the places where my analysis might have a weak link. And that's what I meant about being transparent. And if you can learn how to do that, not only discursively, but using statistics and using graphics, then you're really starting to get a handle on how ethics, at least in the representation of uncertainty, becomes important. And I think there's other things as well. We talk to students a lot about stakeholders and their bias, and the students kept saying, well, these contractors don't have jobs, so we can't believe their data. But of course we can believe their data. It has nothing to do with their income. It has to do with their purpose in the particular case study. And so you can use this as a teaching moment. And so the ethics it's all wrapped up in the same thing. And I really appreciate your comment.
Yeah, I think ours is not the only discipline that appreciates the power, the effectiveness of case studies. Thinking about even Harvard Business Reviews, how I don't know, for 100 years they've been disseminating their case studies, and they're very powerful for sharing ideas that touch on lots of variables and attributes within a problem. I put the link for the convergence curriculum in the chat. And Eric, I'm going to have to hop off this to get on something else, but maybe too, I know some of our open educational resources are available on the iGuide platform. And I see you've got some other great questions to look at here in the chat. So thanks again to Babs and Eric, and I will see you all soon.
Yep. Thank you, Diana. So Diana has to run. I will stay on as co-host, so it shouldn't end as soon as Diana hops off. Fingers crossed. And yeah, I added a link to the Convergence curriculum webpage where we will link to Eric's webpage in the curriculum material as well as Babs's material. So this recording will also be placed there, and you can also see the previous recordings through the development of the curriculum and other webinars that are related to education and workforce development. I do want to, quickly answer these questions. So Micah asks, do you find that students learn best from local case studies, or are global problems better, and how do you strike a balance? So I'll pass that to Babs and or Eric. As a person who comes from computational sciences, I'm scared of the great outdoors, so I never go anywhere. I just sit in front of a keyboard, so I think that they're going to be better positioned to answer this question than me.
Yeah, I think you can get case studies from global examples as well as local. And since we're all citizens of this planet, global problems are as local as they get. You know, I haven't taught many astronomers, so I don't know what they think about, you know, the galaxies and so forth. That's kind of scary to me. I'm with Eric. I've never traveled in space. But the global problems can be just as interesting as the local ones. This just happened to be an example where there was lots of messy data and lots of very, very beginning level students. And so I wanted to use that as an example.
All right, I didn't want to cut Eric off in case, but I will try to get to Lorraine's question here of how do we teach students how they can assess uncertainty in geospatial data in this new world of GeoAI when we do not always know how the data were generated. Yes, this adds yet another, yet another layer on top of the already layered uncertainty. So I don't know if either of you want to address this. Otherwise, I can make a quick comment on a couple of discussions that I've had on this topic too.
I'd be interested in your discussions. My response to her question is yes. How do we do this? This is tricky. So you might have better ideas, Eric.
Yeah, so I'm also part of a GeoAI curriculum development effort as part of AI for Good. And we've had a little bit of discussion around this, trying to figure out at the various levels of how do you kind of communicate the uncertainty both in the data and then once it goes through some of these models that like we don't fully understand. There's not the same quantitative bounds that, you know, Babs was talking about. As if you can get a statistical piece to it, then you at least know, you know, here's my error bounds to some degree. Um, with AI, you know, it adds a lot of complications. And one of the things that I think sometimes the us academics tend to forget is also there's kind of different levels, right? So there is the data scientist or the GISer who's running the models and has really deep expertise and really wants to do this and talk about all the nuance. And then there's the decision maker who doesn't actually necessarily need all of that detail and doesn't have time to really go through all of those things. So in that case, how do you highlight like these are the three big things, right? We all know it's all going to be messy and not everything's perfect, but here's like the three critical things that coming out of this model with this data in this context that like you know you're seeing this plot or you're seeing this map or you're seeing these data, but these ones here we're really not very confident about. How do you communicate that to some level of degree? And especially we can bring up a major topic of scale. You know, data are going to be at one scale. The AI model may or may not operate at that scale. And then how do you kind of communicate that back? And that you know has had a long discussion in the literature. And one of the things that I was starting to work on was actually it's still in development. It was a crazy idea, but I'll throw it out there. Was what I was calling a GeoAI confidence card, which was basically just like this like one pager saying, you know, here's the scale that the data were at, here's the scale that the model was executed at, here's like, you know, room for about 4 bullet points of high level things of, you know, we really kind of feel confident about this, we don't feel so confident about this, and like that's it. Because for decision makers, like that's all the time that they have. You give them anything more, they won't even look at it. You can't give them a 9-page report with all of the details. So so we were kind of playing with that idea a little bit, and I think a lot of it comes back when teaching students, because I've talked about this in some of my classes, is trying to hit the right level of detail. I think a lot of times we really want to go too deep, And that becomes a little bit of a challenge. So long-winded answer to say it loops back to a lot of the things that we've been talking about for many, many decades in the field, but does add yet another layer. All right, I am going to, oh, Karen also made the comment that case studies hit higher levels of Bloom's taxonomy. Yes, absolutely. So it gives you a chance to, get all the way up there in the educational clouds of Bloom's into the create, which is fun. So I would like to sincerely thank Babs and Eric for all of their time, not just for the presentation, but of course all the work that goes behind behind the cool stuff that was presented. And thank every one of you for taking the time. Sorry we went a few minutes over, but we greatly appreciate your attention. If you are interested, we will post all of these materials. This recording, all of the links will be available on that webpage. And thank you again. Stay warm for those of you who are maybe up in the cold north like me. And we will see you at the next VCO for iGuide. Thank you, everyone.
Thank you.
Thank you.